Hello and welcome to Jumpstart Your Cloud Native Journey with IBM Cloud and Kasten. Today's webinar is sponsored by Kasten by Veeam and IBM Cloud and produced by Actual Tech Media. My name is Scott Becker. I'm from Actual Tech Media and I'm excited to be your moderator for this special event. Now, before we get to today's great content, we do have a few housekeeping items that will help you get the most out of this session. First off, we want this to be an informative event for you, so we encourage any questions in the questions box in your webinar control panel. Not only will we have team members responding to questions during the live event, but we'll also have a dedicated Q&A session at the end of the presentation where we'll discuss in greater detail some of the top questions that you ask. That Q&A panel is also the place to let us know about any technical issues that you might be experiencing. A browser refresh will fix most audio, video, or slide advancement issues, but if that doesn't work, just let us know there in the Q&A and we'll provide further technical assistance. Now, in the handout section of your webinar control panel, you'll find that we're offering a lot of great resources. There are 3 PDFs there from Kasten and from IBM. There's one on Kasten K10 Kubernetes data protection. There's one on the data management platform with Red Hat OpenShift. There's the slide deck that you'll be seeing throughout the presentation. And then there's also some links in there about using Red Hat OpenShift with Kasten K10, one to try Kasten K10 for free, a blog about integration and some best practices documents. So a lot of great resources there to check out. I highly encourage you to download those or click on the links throughout the presentation there in your handout section. Now, at the end of this webinar event, we will be awarding a $250 Amazon gift card to one lucky registrant. Of course, you must be in attendance during the live event to qualify for the prize. Official terms and conditions of today's prize drawing can be found also in your handout section. Just have to scroll past all those other resources down to the bottom and you'll find the prize terms and conditions link there. Now, finally, one of the best benefits of this event is that opportunity to ask a question of our expert presenters. So to help encourage your questions, we have a special additional prize for you. That's another Amazon gift card, this one for $50 for the best question. So after the event ends, we'll look back through all the questions that came in, pick out the best one, and contact that prize winner. So with all that out of the way, let's get to today's fantastic content. It is my pleasure to introduce you to our presenters today. We have Chris Rosen, who's Product Management Director for IBM Cloud. We have Matt Bader, who's Principal Kubernetes Native Solutions Technologist for Kasten by Veeam. And for the Q&A portion, we'll also be joined by Satish Mohandas, who's a Solutions Architect with Kasten by Veeam. So Chris, the floor is yours.
All right, thank you, Scott. So thanks everyone for joining. Really excited to have you with us here today. My name is Chris Rosen. I'm Director of Product Management in IBM Cloud, responsible for kind of our innovation stack, the capabilities that enable our customers to focus on what's really important to them around innovation and solving their business challenges. So we're going to take you through a presentation today. Really excited to have my partner in crime, Matt Bader, here with me. Matt, would you like to introduce yourself?
Yeah, thanks, Chris. Great to be doing this with you. So as you said, my name is Matt Bader. I am part of the Kasten product team as a solution architect, focused on how we're enabling our customers, our partners, in terms of running persistent workloads on Kubernetes and how to do that effectively in production.
Very good. So let's get into it. Let's start looking and thinking about hopefully what is not new to everyone here. And when we think about kind of the market opportunity with containerization, with Kubernetes, for those that follow along with the CNCF and participate in things like KubeCon and other events, this won't be new to you. But if you're not as familiar or you're still thinking about that journey, the transformation, the modernization of existing applications or building net new containerized applications, then we'll spend a few minutes here and kind of talk about the opportunity and really the tremendous growth that we've seen in the ecosystem from a lot of different perspectives. And obviously, when new technology starts to grow and we see a lot more adoption of that technology, it will start to bring new challenges to light. So one of the things, when we think about containers and the need of packaging up all of your application and your dependencies is one thing, and being able to run that in different environments consistently, that's really why developers gravitated here early on, is to abstract themselves, because we've all been in the problem or in the situation where, it works on my laptop, it doesn't work on yours. Clearly, it's your problem. Good luck. Well, containers abstracts that. So when we think about pain points, it's not only how to be able to run these cloud native applications, but it's also the reality that it's complex. There are a number of open source projects and moving components when we think about how we start to build the compute, the network abstractions, the network overlay, the storage drivers. And it really is quite a daunting task as you as an organization start to think about who's the persona that will actually build and operate these things. Do I want to go down a do-it-yourself path because I think about the premise of open source and free, and I can build those things? And true, open source is free, but it's not easy. It's very challenging to build those things, stitch them together. Think about lifecycle management. How do we maintain vulnerability remediation, operating system updates, everything that will go, the longer these environments live, new risks will come out. So how do we think about and where do we need to be able to run that environment? So it's, do I want to do a do-it-yourself? And therefore, I need quite a skills investment to be able to build in those operational characteristics with high availability and compliance and disaster recovery and all the things that are going to be really important as we go down this journey from kicking the tires with a proof of concept to running ultimately production workload. Do I want to run in public cloud? Do I have a public cloud provider already? Do they have the set of tools and capabilities and compliance and controls to keep my workload protected that enable me to move that workload to that given cloud provider? Do I have use cases where maybe I want to run some cloud native workloads in my existing data center or in other edge type locations? So there's a lot of areas where we need to think about architecting properly, else we'll really dig a lot of additional challenges as we're going down this container path.
Having lived the DIY version of this a couple of times, any opportunity to hit an easy button is often welcome, and I think IBM Cloud here is the idea is to present users with exactly that, right, Chris?
Yeah, absolutely. So those that may be unfamiliar with IBM Cloud and some of our focus, when we think about building in, it's the operational characteristics. And I know I've said that already, but it's really about raising the line of responsibility so our customers can focus on what's important to them, because it's generally not building Kubernetes clusters. It's solving what are my real business challenges? How do I drive efficiency of the underlying infrastructure? How do I make sure I'm highly available? So when we think about IBM Cloud, that's where we're focused. It's around resiliency, driving down any impacts or issues, building in, how do I do lifecycle management? I want to run wherever I need that workload to run. We also build on top of IBM's heritage environments with different architectures. So our customers that are running Power or mainframes and Z in their data centers, they want to be able to modernize that in a cloud-like manner with the elasticity, the on-demand nature of these resources as they start to modernize to an x86 or a Red Hat-based Linux solution. Also, we see a number of workloads, whether I'm coming in on VMware and I'm bringing my infrastructure as a service estate, and then I want to modernize those applications from monolithic virtual machines to a container-based approach. And then as we layer on top of that, and we think about Red Hat as kind of the abstraction layer to run all of our containerized workloads, regardless of the underlying infrastructure that they're running, it's adding additional capabilities, because it's not one solution that fits everything. When we think about our customers' problems, it really is a diverse set of challenges that they need a wide variety of solutions to solve their problems and enhance their applications by adding in IoT insights or machine learning and cognitive capabilities to be able to create a more engaging user experience. So when our customers are running chatbots or different applications that come in, if I'm an end user of that platform, I want to make sure I'm getting directed, I'm getting the answers in a very responsive and accurate manner, so I don't have to call someone and ask for, whatever the data is I'm trying to gather. And then on the right-hand side of this, it's all the peripheral capabilities that everyone needs, that think about, the electricity in your house, that it's just there when you need it. And you don't realize how important it is until it's out, but that's where the metrics, the logs, the activity tracker, the encryption, all the things that are always there for all of your applications and available when there is some issue, either at the application or the cluster level in that environment. The other point I want to touch on, because I mentioned this earlier, when we think about maybe not everything is ready to move to public cloud. And we've seen a number of use cases where that may be the point, where either I'm running workloads in my data center already, and I don't want to just lift and shift it as is from data center to cloud and then modernize it. Instead, maybe I want to bring that cloud native stack into my data center. Now I have access to these modern technologies in proximity to other resources that I have running, to that monolithic app, to a database. So when we have concerns with data sovereignty, maybe, whether it's government policy or regulation, whatever the case may be, that my data cannot leave a particular country, or even more fine-grained down to the data center or city level, that I can now run those workloads there. Or the other use case, when we think about places that don't have Kubernetes experts, and that's retail, it's kiosks running in fast food restaurants, it's manufacturing plants that need to be able to process data and run things. But again, they don't have a lot of OpenShift or Kubernetes experts in those locations. So this is where IBM Cloud Satellite can come in and help eliminate some of those challenges for our customers, and again, let them focus on what's important to them, which is running a solution, not underlying infrastructure. If you're familiar with what Gartner would refer to as distributed cloud, other analysts would call it local cloud as a service or data center as a service. It's all the same premise around how do I take a fully SRE managed service running on infrastructure that's not owned by the cloud provider. So in our case, with IBM Cloud Satellite, now we can run a managed set of capabilities, whether it's OpenShift, it's databases, it's event streams, object storage, so on and so forth. We can run that in any infrastructure. If you have an existing footprint, awesome. Let's reuse it and deploy there. If you don't have it, but you like the premise of being able to roll something off the truck, network it, power it, well, we can do that too, because we have a full hardware appliance where we can layer on these cloud native PaaS offerings on top of it. And regardless of the situation, that allows our customers to focus on deploying the Cloud Pak software, the solutions that they want. Could be ISV, they could be building and running their own. And just one example that really resonated with us was, think early COVID times, we were working with the University of Mainz Hospital in Germany, and they had very stringent rules around the fact that patient data could not only not leave Germany, but it couldn't leave the hospital. When they were tracking things like testing and the early vaccines that were very date driven between vaccinations, depending on the one that you got. So this was all new to them. How do they track that reliably? And again, not a lot of Kubernetes experts running around in these hospitals. So we were able to use IBM Cloud Satellite, deploy these managed services, And now they could track all of that in real time, in proximity to where their patients are, and ensure that they're meeting all of the government regulations from a very strict healthcare perspective within Germany.
So it certainly sounds like that covers the first big piece of the puzzle here, right? From not just obviously an infrastructure perspective, but all of those extended services that I think you mentioned. Where are we raising this bar of responsibility or value that a customer is then creating? So I think that helps get us through day zero. But what about our next challenge?
Yeah, absolutely. So you're right. So as you're going through this journey, and everyone is at a different point. Obviously, if you're born on the cloud, then you live in containers and functions every day. But that's not the reality of most of the customers that I speak with. It's an evolution of challenges. So the next set is really when we think about the developer persona, which is really where we're targeting to solve those challenges. What they want to do at the end of the day is push as much code as quickly and as securely as possible. It comes down to innovation. They need to be able to solve challenges for the business. So how do they do that? How do they do that in the confines and the controls, and thinking about shifting left our security controls, so that way it's not just a checkbox at the end of the CI/CD pipeline, but we integrate those tools in a seamless manner, because developers want to adhere to the company policy and not delay their projects from being released, but they also don't want to become CISOs and learn all of those complexities. So we're really focused on building in the tools and insights earlier on in that CI/CD pipeline to ensure that they have the same velocity to be able to innovate at the speed that they want. Because again, that's really what the developers want to do: hands on keyboard, build new feature function, and get it out to their consumers. But also, obviously, they don't want to knock at the proverbial door from the security team saying you violated this and we need to re-architect and think about how we're building and running our applications. So the next thing we'll talk about is Red Hat OpenShift on IBM Cloud. Is we're drilling down into the offerings and we're thinking about that use case around innovation. There's a lot of solutions that will go into solving that in a properly architected application. The core for us in IBM, and one of the drivers for our acquisition of Red Hat, was OpenShift, to give us that consistent platform to be able to run these containerized workloads in IBM Cloud, in your data center, or in the other public hyperscalers as well. So because OpenShift is OpenShift, there's no different versions. We want consistency. That's the core at our broader IBM strategy, is having that as a common abstraction. So how do we differentiate in an IBM Cloud? So that's what we'll talk about now. And it's providing not only the day one user experience around, there's a lovely UI, and you'll see that in the demo here with Matt shortly, where you can point and click through creating a cluster, building in those operational characteristics with highly available master nodes, multi-zone clusters, which now will distribute masters and workers across 3 physically separate data centers within a multi-zone region. So if there is some catastrophic top of rack network outage in one of those data centers or zones, that's okay. My API is still accessible. I can still deploy workloads. I can scale out. My microservices are running. I can use auto scaling capabilities to make sure I've got the right capacity to run my given workload. Same premise when I'm upgrading from Kubernetes or OpenShift versions, that we do so in a controlled rolling manner, so that way your development teams don't know that the upgrade is taking place. Your customers that are consuming your applications, services, websites, chatbots, etc., don't know that we're going from Kubernetes 1.22 to 1.23, for example. Now, the reality is my customers will use the UI once. Then they're going to automate that for consistency, whether that's infrastructure as code like IBM Cloud Schematics, which uses Terraform and Ansible, or some other automation tooling. Really what's important to me is that you automate those things for the repeatability and have the control over who can deploy what. running that workload in any of the regions that we support. Of course, also through IBM Cloud Satellite. So if you need to run this managed service in your data center or these edge locations, we can do that as well. We have an industry-leading 99.99% financially backed SLA. We're really focused on that resiliency because whether you're running production workload, obviously we need that available. But even for our dev clusters, if the cluster's down for whatever reason, then that team may be sitting around waiting for the resources to come back up. So we're really, really dialed in on availability of the environment. One of the other things that we think is unique is engaging with our customers through Slack. And we'll create a private channel. So it's my team, it's your team. We can bring in Matt if we have Kasten by Veeam questions. And it creates kind of this private little bubble, this enclave for us to be able to have these conversations and understand use cases, issues, architectural reviews. But again, as you're going through this journey, there'll be different steps where you'll have questions. So on the far right side, thinking about, yes, I could stand up Grafana or Prometheus in my cluster, but let's raise that line of responsibility and use managed monitoring and logging services. So I've got one place to send all of my metrics and all of my logs. Now I've got those custom dashboards, I've got custom alerts, I've got integrations with whether it's Slack or text or email or however your teams need to be able to receive that data in an efficient manner. You can set up those integrations in those webhooks. Key management is very important as well. Now, every cloud provider has what we would call a bring your own key capability. And ours is called Key Protect, where you bring your keys, you can revoke them, pretty standard across the industry. We have something that we call Keep Your Own Key using our HyperProtect crypto services offering, which leverages FIPS 140-2 level 4 encryption. Now, you're probably thinking, Chris, that sounds really nerdy. I don't know what that means. Essentially, it's the technology base, the foundation to trust in our offerings, because the other cloud providers have a policy assurance that they won't access your applications and your data. Only in IBM Cloud, with our Keep Your Own Key and our level of encryption, is there a technical assurance that we don't have access to your applications nor your data. Think about a complete bubble around all of your resources. And that really is the foundation of trust that enables us to provide an emphasis on our financial services customers and going through that validation process to be able to run that highly regulated workload. Yes, front-end applications, things like that, they can probably run anywhere without any risk. It's the mid to back level applications that are under much more stringent regulation and oversight that they need this type of level encryption to be able to move those workloads to cloud. And that's really why, you hear a lot of analysts talk about only 20% of workload has moved to cloud. Well, that's because the rest of it is hard. It has a lot more oversights to it. So this is enabling us to work with those customers. And it's really regardless of industry. We started with financial services. We automated those controls. There are over 550 that we get insights and surface that through Security and Compliance Center. But we've also found that 90 to 95% of those controls, because a lot of them are NIST-based and et cetera, are applicable regardless of industry. So if you're in healthcare or government or retail, that those will apply to you as well and help ensure that you've got a seamless migration to cloud.
So, Chris, I love this is a very this is a dense slide, but I want to make a couple of points that I find really interesting. Is again, we're not talking about just this is simply a managed service for OpenShift. There is so much else here where IBM Cloud really is focused on, again, what are any additional gaps that exist to get a customer to production, and interesting on the engagement piece as well. I find fascinating because every customer is going to be a little bit different, right? People have different concerns, and being able to work kind of hand in hand with not just IBM Cloud, but then the rest of that partner ecosystem to identify those gaps of what might be needed for a particular solution, I think is great, and really leads me into the next thing that we wanted to talk about, which is those day two considerations that maybe weren't super high on the list, maybe just not from an interest perspective, when there's all of the excitement around going down the path of new infrastructure and new applications, and ultimately, like, we know the why behind how we got here. We know why people are wanting to go down the cloud native path and build or migrate applications to Kubernetes, right? It gives me speed at the end of the day, right? I'm able to bring new features, new services, new products to market faster, and regardless of industry, that provides a lot of competitive advantages. But ultimately, just because something moves fast doesn't mean it shouldn't also be safe. So we saw that, reflected again on your previous slide of all of these other security focused considerations that IBM Cloud has made. And the other that I obviously want to layer on top of this is that, well, we see a car here on this slide being built. Like, that principle holds up very well there. Just because a car goes fast doesn't mean it shouldn't be safe. I think the same thing, is equally as much a consideration when we're talking about cloud native applications, and in particular the data that's associated with those applications. We see some considerations here, things like on-demand cluster scalability. How do I auto scale a cluster, and then subsequently, my applications running on top of it, that having a flexible managed solution like OpenShift running on IBM Cloud can solve that for me, or the ability to deploy in very specific regions to help meet certain data governance requirements. But there are some key gaps here within Kubernetes today that the platform itself just naturally does not address. And those big ones are really around data protection, right? So backup and recovery, disaster recovery, and even specific to Kubernetes. Again, one of the big motivators to go down this path was that aspect of portability. You use the phrase, well, it runs on my machine, which is one of my favorite phrases to kind of summarize why Kubernetes. It's to solve that problem. But what happens then when we want to focus on how we get those applications between one platform or another? So this is the next topic that we want to address. But again, why? I still in 2023 hear a lot of, well, why should I have to worry about disaster recovery or backup for Kubernetes? It's all stateless, isn't it, Chris? All Kubernetes apps are stateless. Is that still the case in 2023?
I wish that was the case. But you're absolutely right that there's a misconception around this need, and we run into it with customers where, they think about the value that we're providing from a cloud managed perspective and the things that we're backing up, but there's a layer that's not, and the customer is responsible for that. And I think that's exactly what we're about to tee up here.
Yeah, absolutely. It's, really the nature of applications on Kubernetes has changed significantly. Even within the last 3 or 4 years, as more and more functionality on the platform has made it possible to run stateful workloads or persistent workloads on Kubernetes. There's an obvious desire to want to do this. The graph that you see on screen now is just one data point to that effect of just off-the-shelf container images, again, common in containerized environments. Across that list, a significant portion of those are data services, or more specifically, databases. Databases on Kubernetes are becoming increasingly commonplace, mostly because it allows me to streamline the development and management of an application. If I'm still dependent on some external monolithic databases for my application, they might not be able to move at the same speed as everything else, right? So there are natural benefits to wanting to go what I would call all in on my application components for Kubernetes. So we see that happening all around us. So hopefully, that sort of cements in people's mind why backup matters. If you don't back up your databases, we have bigger problems to talk about. And again, the big why behind that as well is that, hey, just because cloud native is newer does not mean it is not equally as much a target for nefarious individuals in the world trying to make a quick dollar out of under secured environments through the form of various types of ransomware, right? So if I've got my database workloads running on Kubernetes, and it's equally as susceptible to things like crypto mining attacks or crypto attacks in general, I want to make sure I have a way to quickly restore these things. And that, maybe a bit of a slow buildup, is exactly what Kasten was built to do, right? So we are focused on solving these day two data protection concerns specifically for Kubernetes. From a use case perspective here, obviously starting with just in place backup and restore. So whether that is malicious activity like I just mentioned, or even your day-to-day accidental deletion, the ability to quickly restore, granularly restore some portion of my application, an entire application to a point in time, is very important. Chris, you had mentioned before that CI/CD is a big driver, or GitOps is a big driver of why Kubernetes, right? So I'm able to constantly be deploying my app into production. That Git pipeline is great for standing up a clean copy of my application and being able to do that very repeatably. But if I've got persistent volume data associated with those applications, my source code repository isn't going to help me get that back, right? So we see a lot of deployments where we're concerned about integrating that backup workflow into the overall CI/CD pipeline. So that's a very common use case. And then your entire site disaster recovery, right? So when I lose an entire Kubernetes cluster, how am I able to quickly bring back all of those workloads, or again, from a granular approach, some subset of those workloads in other locations? And as I previously mentioned, application mobility being this really interesting capability that Kubernetes offers because of the portable nature of container images themselves. But again, once I've got that persistent volume data associated with my app, I now have to overcome this data gravity to be able to do things like moving between different clusters. So let's say I have a new data governance requirement that's going to require me to relocate a workload into a different IBM cloud region. How would I go about achieving that? Or how do I go about migrating a workload between clusters running different versions of Kubernetes, right? I'm doing some other testing or cloning for dev test type workflows. So all of these are the key kind of use cases that we're seeking to solve with Kasten K10. And from a how perspective, right? We've talked a little bit about why this matters, but I want to cover, how do we think about this space? How do we think about the capabilities required for an enterprise to be able to solve this problem? And the first thing that we focus on is being what we call Kubernetes native. So there are data protection solutions for Kubernetes that might simply talk to the Kubernetes API in order to capture objects, capture application metadata, and perform some storage snapshot automation, but are not necessarily what I would call Kubernetes native. So Kasten K10 runs on your Kubernetes cluster, and it's built off of Kubernetes custom resources. This means that from Chris, you mentioned the first time I might do something, I want an easy to use UI that I can go in, make some changes, makes tools, considerably easier to adopt. But as we get more mature in our use, automation becomes the focus of everything. And again, being Kubernetes native, our API is the Kubernetes API, and vice versa, makes it significantly easier to start thinking about, how do we capture our infrastructure as code for all of our data protection policies, the same as I would for my actual Kubernetes applications themselves. How would I look at automating, performing different tasks through Kasten the exact same way that I would using my existing, Kubernetes tooling stack. So that's an incredible benefit just right out of the box. And that kind of trickles through a lot of these other items. So security everywhere is not just thinking in the same way that IBM Cloud is differentiating their managed OpenShift offering. We're not just thinking about security within the Kasten product itself. So from a cryptography perspective, making sure that everything is encrypted at rest and in flight, making sure that you have support for immutable locations to store your backup data to ensure that it's safe against things like ransomware attacks. But also, all of the security considerations that surround the product that, again, help it plug into the rest of that tool stack. So from a Kubernetes native perspective, being able to work with native Kubernetes role-based access control roles and assignments, or even the Kubernetes audit log to be able to capture all of my Kasten actions as a part of that Kubernetes audit log. So who has gone in and made some change to a policy or attempted to delete a restore point, being able to have, full visibility into those things and really being able to lock down your self-service experience that you might be giving to different teams. So security everywhere is definitely a key pillar of the product. And then just supporting a very broad ecosystem, not just from different cloud providers or distributions like OpenShift, but also from an applications perspective. So there's an incredible variety in the different data services that you might be running on top of your Kubernetes environment. So your MySQLs, Postgres, Mongo, Redis, so on and so forth. Being able to ensure that you've got application level integrations and the flexibility to support new applications as they come up on the platform is a critical area for us. And then we'll see this coming up here in the demo, just ease of use. Chris, you'd mentioned there just aren't that many Kubernetes experts out there in the wild for organizations to be able to pick up like their leaves growing on a tree. So how do we make that solution very easy to adopt? I think the other, one of the other areas in this space that people don't quite understand is, there's a data protection team in most organizations that are responsible for NAS and responsible for virtualization and can really kind of own that in an end-to-end fashion. Data protection for Kubernetes is fundamentally different in that it requires infrastructure operators to have more understanding of the applications that are running on them, and vice versa. There are roles here for both development and operations. So you really need to be able to provide the right kind of interfaces and APIs to support those different user groups. And one of the other differentiators to point out here is just speed. So we see 3+ major Kubernetes releases per year. OpenShift typically falls very quickly behind that as well. Public cloud operators constantly adding new features and capabilities. Kasten does not operate like a traditional data protection solution that might drop 1 or 2 major updates per year to what we offer. So we move really at the same speed that our customers are developing their own applications. We have a bi-weekly release cycle, which is allowing us to constantly add, obviously fixes, security enhancements, but also significant new feature capabilities to the product as well. So this is just a summary slide from some of the big pieces from our last major release that I won't get into, but it's just to make that point that again, you need a solution that operates at the same speed as the cloud that you're running on, the distribution of Kubernetes that you're running on, and ultimately the applications that you want to run on that platform. So just to visualize this from where Kasten really fits in this stack. So we saw going through day 0 through day 1 on the IBM cloud side, and being able to consume my managed OpenShift on top of that is providing me with all of those operations focused insights, my developer focused tools and consoles. And then, as I mentioned before, Kasten K10 sits on top of that same cluster. So this is not a separate appliance or agent or SaaS solution. This is, again, running directly on each one of these individual OpenShift clusters, and then responsible for the protection of these, specifically these data or stateful workloads running on top of that cluster. So we see, again, Postgres, Mongo, many different flavors of SQL, Cassandra, and really giving users the flexibility through what we call blueprints to write their own application level integrations to support any custom requirements that they might have in that environment. But all of this is, I guess, somewhat meaningless if it's not easy, again, to get started. And that's what we want to look at is, so first, from a just getting installed, consuming it on the platform perspective, Kasten K10 is Red Hat operator certified. So we do offer a level 3 operator directly through the OpenShift operator hub, making it very easy, as we'll see in the demo, to get deployed on the platform, as well as deal with any type of future upgrades to that Kasten software as well. And also, not just through the operator hub, but I could even deploy as an add-on directly through the IBM cloud platform as well. So we'll go ahead and transition here over to a quick demo, as I mentioned, to show you what it looks like just to get up and running with Kasten by Veeam on IBM Cloud. All right, so starting from the very beginning here, we're actually going to deploy a net new OpenShift cluster on IBM Cloud. So we'll see them just going through and making a few small tweaks here. So we're just naming my cluster, and we can make some selections on built-in integrations that we may or may not want to include. But otherwise, it's as simple as hitting the create button and sitting back. And within about, what would you say, Chris, 45 minutes to an hour, a little over, I've now got a production ready, as you mentioned before, multi-zone if required, OpenShift deployment ready to go. So we can just go ahead and launch that OpenShift console here. And now that we've got that brought up, I'm going to go ahead and use the IBM Cloud tool to get authenticated into this cluster. And we can see our three different nodes available and all of our current OpenShift namespaces. So the next thing I'm going to go ahead and do is install OpenShift Data Foundations to use as my underlying storage. Although you could also use the IBM block storage as well, as that also supports volume snapshots through their CSI driver. And once that's installed, we'll just go ahead and make that storage class the default within the system, and mark its volume snapshot class the default as well. Great. So here we're just adding those annotations for the snapshot class. And this is just so Kasten, once installed, knows which volume snapshot class to request storage snapshots from. And then within the OpenShift console, we'll create our project or our namespace for Kasten.io and go right into the operator hub. We can search directly for Kasten here and select our operator to start installing. And we'll go ahead and put this into our Kasten.io namespace and start our deployment. So again, within typically about 2 minutes, my cluster should be up and running here. So if we view within our operator has been deployed. So now we can actually deploy our instance of K10 using that operator. So we'll just do a quick status check here. We can see all of our Kasten pods are running within that namespace. We'll just do a quick port forward to be able to see the UI, but that could be exposed via a route, a load balancer, etc. So once I'm in the Kasten dashboard, we'll see this is separated into applications, our policies, and then just some reporting and activity. So here we see all of those application namespaces already available within that cluster. But before we protect our app, we want to create what's called a location profile. Location profile defines where we're exporting our backup data to, because we know that our local snapshots, right, that's not really a backup. So in this case, we're actually going to be using the IBM Cloud Object Storage, which is S3 compatible. We're going to specify my credentials for that and add that as our location profile. So as we take backups, they'll be shipped off of the cluster to this bucket. And we can see I've got a WordPress application installed on the cluster. It's got multiple disks associated with it, deployments, config maps, etc. And we'll go ahead and create our policy. This is a simple matter of just which namespace do we want to protect, where do we want to export that data, and go ahead and kick that off. So here we're discovering all of that application metadata from the cluster, snapshotting the storage, and that will also, again, be exported to that IBM object storage. But now that that initial backup has completed, even before the export's completed here, I can go through and see I've got my local restore point available for my WordPress app. And rather than restoring over it, we'll actually create a new namespace and restore this backup here with all of that same data, all of that application metadata, to a separate namespace we're going to call WordPress clone. And that restore, because it's restoring from local storage snapshots, should be quite rapid. So we see here that was just over a minute to restore that app, which if I go back in here and look now, we see running. And if we just do a quick git pods on that app, we can see that, yes, our MariaDB database as well as the web tier for my WordPress app are running, and my services to access them are available as well. So that's our very rapid fire demo on getting started with Kasten K10 running on top of IBM Cloud. And again, there are many different use cases here, whether we're talking about, that dev test cloning, in place restores, application mobility between different clusters, failover from my satellite IBM Cloud on-premises location to an IBM Cloud public cloud location, or vice versa. The sky is really the limit with what you can accomplish with Kasten by Veeam. But I hope this quick look gives you a good idea of how you can get started.
All right. Awesome demo, Matt. I really appreciate that. I hope everyone can see how easy and intuitive that we've made this between IBM and Kasten by Veeam to be able to protect that workload. And when we think about the journey and the different steps that you may be on and where you start to process and think about building clusters, building your first containerized applications, and then ultimately, as you move them into production, the value of Kasten and its industry-leading capabilities to be able to protect that workload and support a number of different use cases. And as Matt talked about, whether it's backing things up, it's putting it into your CI/CD pipeline, it's your persistent storage, it's the need for migrating clusters from one environment to another. Maybe you've started in a do-it-yourself path and you quickly realize that it is hard to run these things. So I want to be able to back it up and restore it into a managed service environment and continue operating. So again, a lot of different scenarios and use cases that we can come together and collectively help accelerate your journey and your value and help you solve your business challenges to really derive the most value from the partnership between an IBM and Kasten perspective.
Better together. You said it, Chris. Thanks for taking the time to be here with us, and thanks to all of you for joining.
Okay, great presentation there, Chris and Matt. Nice demo, Matt. Looks like we do have some questions coming in here. Satish, I know you've been active in addressing audience questions in the console. Are you ready to discuss some questions here?
Yeah, sure, Scott.
All right, super. The first one we have, they're saying we have multiple teams on different projects sharing resources in our current OpenShift cluster. Is it possible to limit access to just their own apps in Kasten?
Yes, absolutely. Kasten as a tool supports role-based access control, and Kasten is Kubernetes native. So being Kubernetes native, it leverages the Kubernetes native API objects such as cluster roles, role bindings, in order to control access to the Kasten objects. So this allows the application teams to be able to have more granular and fine-grained control to the namespaces and the objects within those namespaces, in just the way how they operate. So,
okay, all right, super. Next one here: if I'm already running OpenShift on-prem, could I use OpenShift on IBM Cloud for DR?
Yes, you could use OpenShift on IBM Cloud for DR, and this is where one of the use cases that Matt was talking about, helps in order to set up your DR. So you could have your primary environment being an OpenShift on-prem, and you could have Kasten running on there, which is creating a backup of the applications running on your on-prem, and let's say it's exporting to an IBM bucket. And then you could kind of you build a DR on OpenShift on IBM Cloud, which is then going to read the backup that's being stored in the IBM Cloud, and to be able to kind of build a DR system.
Okay. All right. Super. Here's one. They're asking, we're using operators to deploy and manage databases in OpenShift. Can I back those up with Kasten?
Yes. Kasten does allows to back up the operators, the databases that's deployed as operators in the OpenShift. So this is where the blueprints come into picture. So with the help of blueprints, we could leverage the native databases that are deployed. For example, I could say like a Pergona operator that provides MongoDB, Postgres type databases. So using those blueprints, you could kind of enable Kasten to back up those databases and then export the backup copy to the external location.
Okay. All right. Great. Here's another one. Is there a size limit to the clustered environment Kasten would be able to move applications around?
No, there is no limitations. So Kasten, again, like you could kind of deploy Kasten, and you could kind of create a backup policies as the level that you want. You could create one backup policy that's going to back up all the applications in the cluster versus backing up different applications with the different policies using different backup and restore requirements. So you could kind of define the way how you want to.
Okay. All right. Great. Can I use Kasten to migrate apps from a cluster running an older version of OpenShift to a newer version?
Yes, you can absolutely use Kasten for migrating OpenShift workloads between different versions. In fact, Kasten was one of the most used applications when we had back in the days, when OpenShift released 4.x, and there was no in-place upgrade from 3.x to 4.x. So Kasten was we had a lot of customers that where we deployed Kasten in order to help migrate those applications between different versions. So yes, it's absolutely possible, and in fact, that's one of the major use cases that we see with a lot of customers, being application migration. One of the feature that I would like to call upon is that Kasten provides is called transforms. So as you back up an application and you take the backup and try to restore into a different cluster, whether it's an OpenShift cluster or a non-OpenShift cluster, sometimes there could be some changes that you might have to do based on your target cluster, because maybe you are using a different type of storage on the target cluster, so your storage class is different, or maybe you have a different requirements of maybe you don't want to run the same number of replicas that you used to run on the source cluster. So these transformations can actually be coded in Kasten through the transform sets, and these transform sets can actually be applied as part of your restore process. So when your application is backed up and restored in your target cluster, these transformations are already part of your restore process. So when the restore is complete, you have your cluster up and running with all the required changes as per your target cluster needs.
All right, super. Here's another one. How is Kasten licensed?
Yeah, Kasten is actually licensed based on the number of worker nodes in the OpenShift cluster. So we go based on the count of worker nodes, not on the size of the worker nodes. So for anyone who would want to kind of try Kasten for free, so it's currently available for up to 5 nodes for free. You could use it how much of time you want. It's just that you don't get the enterprise, the support. But yeah, you could try it for free for 5 worker nodes, and the license is based on worker nodes.
Okay, super. Yeah, and I'll point out that in the handout section, there's a link to the place where you can sign up for that free 5-node. Super. Probably have time here, Satish, for one more question. Asking, we're evaluating running VMs on OpenShift with KubeVirt. Can I protect those with Kasten?
Yes. If OpenShift virtualization is enabled on the OpenShift cluster, and if you have any VMs created, then yes, Kasten can actually protect those. So Kasten basically automatically determines or detects these virtual machines and basically treats them as like regular workloads, and helps you to kind of like protect those virtual machines as well. And one other additional feature that I would like to point out here is, let's say, for example, if you have a need to freeze your guest file system of the virtual machine before you're trying to take a backup, so they can easily be done. So you just need to kind of like provide the right annotation to the namespace, and as with the help of the right annotation, Kasten can automatically detect those, and then will freeze your guest operating system while it performs a backup, and then unfreezes it as it's done.
Okay. Well, Satish, this is such a rich area. I wish we could go all day, but we are up on time. So thanks a lot for taking all these questions here. Really appreciate it.
Thank you.
And I also want to thank Chris and Matt again, just for a great presentation and the demo. And one last reminder to everybody: if you do want to get started or find out more about Kasten K10 and in IBM and Red Hat OpenShift, there's all those resources there, and you've got maybe a minute left before we're completely wrapped to grab those. So head into your handouts and pull down anything that you want from there. And before we wrap up, we have one more piece of business. It's the Amazon gift card prize drawing. And the winner of that $250 Amazon gift card is Matthew Larcell from Hawaii. So congratulations to Matthew Larcell. We'll be in touch to get you your card. And with that, on behalf of the Actual Tech Media team, I just want to thank Kasten and IBM again for making this event possible. And thanks as always for attending and for all of your great questions today. That concludes this event. Have a fantastic rest of your day, and we will see you next time.